Good afternoon, my dear students. So today we will be discussing the coordination compounds using top 15 PYQs for NEET, JEE and EAPCET. So I have collected few important questions from JEE, NEET and EAPCET previous year papers. Okay, we will discuss this so that you will get some clarity over this topic and this chapter. Okay, so let me start this session with first question. So here the first thing when it comes to coordination compounds, you need to know, see here we have definitely there will be some metal atom attached with some ligands. Okay, generally I am talking about metal complexes here. So metal complex is represented in a square bracket like this. Okay, so there will be metal atom along with some ligands. So ligands will donate lone pair electrons to this metal. For example, here I have something like this. Okay, so here it represents what? So the square bracket represents what? The coordination sphere. If any anions are there, you can write this side. So for example, chloride ions are there along with this complex, you can write here. So anionic sphere should be considered as here. And if there is any cationic ion, like cations are there, we can write that in the cationic sphere. It means this is the coordination sphere. So this side is for cationic position and this side is for anionic position. I can say this is cationic sphere. So for example, sodium ions are there. So I can write this sodium over here. Okay, since sodium is a cation like this. Okay, now here the question says what is the coordination number? Coordination number is one of the basic thing that you need to know. So coordination number says number of ligands that are present in this coordination sphere, or number of ligands attached to this metal atom, or what are the total number of dentation shown by this ligand to this metal. So here this n represents number of ligands, that is its coordination number. When I am saying this is like monodentate ligand. Okay, so now here you can see iron attached with the 6 cyanide ions right now. So its coordination number is what? Now coordination number of this sphere, this complex, metal complex is 6 here. And look at here, it has 4 chloride ions, therefore coordination number in this case is 4. Very simple. This is appeared in EAPCET entrance exam. Okay, so complex is what? Complex is a composition of both. When I am saying metal complex, it contains one metal attached with the ligands. Now what generally we know, metals are electropositive now. Yes. Now when you keep this metal ion in any of the ligand solution, see ligand solution means you can place in water, or you can place in ammonia solution, or you can place in some other species. Okay, so now what happens, this ammonia or water, let us say I am keeping this in the water solution. What happens, these water molecules will surround this metal, right now metal ion. Right now if you take metal ion, so since metal ion is positively charged, the lone pair electrons on oxygen, that is containing high electron density now, so that will comes and surround this metal atom, okay, in proper orientation, in certain orientation. So that results to formation of this complex. Okay, this is how you can understand. And this is a live lecture, this is not recorded. Okay, those in the chat box I am looking into it. So it's a live lecture, you can listen it properly, consciously. Okay, so I hope it is clear. Now tell me, what is the coordination number of this particular complex? See, iron is a metal right now, so it is having 6 cyanide ions surrounded around the iron. So I can say what is its coordination number? Coordination number here it is 6. Okay, now you have 6, 4 is your answer. So option B will be your perfect answer for this question. Now I will be giving you few more example questions. I want you to identify what is its coordination number. So I am writing in the coordination sphere, I am writing cobalt. Okay, so cobalt CO. Okay, and here ammonia ligands. Okay, I am mentioning here it has 3 and chloride ions 3. Like this I am giving you. Now tell me what is the coordination number of cobalt in this case. Very easy. Look how many ammonia ligands are there. Ammonia ligands are 3. Okay, and as well as how many chloride ions are there? 3. So total number of ligands 3 plus 3, take it as 6. So 6 will be the coordination number of this cobalt in this case. Hope this is also clear. Now I will be giving you one more. Tell me here, cobalt NH4, 2 NH4, NH3, 4 Cl2, and here I am writing chlorine. So tell me in this case, what is the coordination number of cobalt in this case? Very easy, it is also. Very easy. Yes. See here, you need to consider coordination number only to those ions which are present in this square bracket. See, along with this metal in the square bracket, along with this metal, you have ammonia ligands 4 right now, and here 2 chloride ions. Only this is your coordination number, and these are only considered as ligands here. This out of the coordination pairs ions are not considered to calculate its coordination number. This is nothing. Do not take, that is just a anionic sphere. So total coordination number is 6, 4 plus 2. That's it. Hope it is also clear. Now these are monodentate ligands. Sometimes you have polydentate ligands or bidentate ligands, I can say, or like tridentate, tetradentate, hexadentate, like that. So let me take here CO, OX 3 times I am writing here. So what it is, see OX, here OX is what? OX represent, it is oxalate ion. What is that? Oxalate ion. So oxalate structure, what is the oxalate structure? So it is like COOH, now oxalic acid means I am writing here COO minus and COO minus. See, so one oxalate contains, see OX is a short form of or short representation of this oxalate ions. See, one oxalate ion like molecule contains so 2 dentating sites like this right now. So I can say that as bidentate ligand right now. So one oxalate can donate 2 sites, 2 ligating sites are there. Therefore 3 sites, 3 oxalates are there. So you can say 3 into 2. Why 3 into 2? So each oxalate has 2 donating sites. Therefore totally 3 we have oxalates. So 3 to the 6. So what is the coordination number in this case also? It is also 6. Coordination number here also 6. Hope it is clear. Hope it is clear. Yeah. So hope it is clear. Let me move forward. Yeah. So here you can see increasing order of field strength. Yes, we will come to this after some time. And again, you know, you need to also know how to calculate oxidation states. So how to calculate oxidation state? Let me take the first question itself. See, the first strategy is you need to know what to or how to say its coordination number, and the next thing is how to calculate oxidation state. Very basic things. So only after knowing its coordination number and oxidation state finding, then we can move further for other concepts of this coordination compounds. See here, I'm saying you to calculate what is the oxidation state of this iron in the complex. So let us say for iron it is X, that value of X we need to say. Oxidation state of iron here X I am taking, and 6 cyanide ions are there, 6. Each cyanide oxidation state is -1 right now, and overall charge, what is the total charge present on this complex? -3 now. Take it is equals to -3. So X will be -3, and this side -6, send that side, it will becomes +6. Okay, so overall charge will be +6. The oxidation state of this iron here is what? +3. This will be the oxidation state. Now what is the electronic configuration when it is in +3? So you should write, for iron atom we know atomic number is 26. So you just simply write 3d6 4s2. 26 now, so 3d6 4s2 now, like 26 now, 2 means you can write 4s2. That's simple way of remembering. Okay, so this is the electronic configuration in its atomic state. Now I am asking in its ionic state like this, +3. So how do you do? Remove 2 electrons from here, so 4s0 it becomes, and 1 more electron from 3d, so it will become 3d5 4s0. So this is how you can able to write the electronic configuration in its oxidation state of given respect to ions. Now can you tell me what is the oxidation state of iron in this case? In this case, just I want answer for that. Anyone? Yeah. So tell me, what is the oxidation state of iron in this case? See, iron take X and 6 cyanide 6 into minus 1 equals to what is the total charge present on it? Minus 4. So you will get iron oxidation state as plus 2. And for this, see, iron here it is, consider X for iron and 3 chlorines are there. 4 chlorines are there, 4 into minus 1, overall charge is minus 1. So it will be plus 3. So this is how you can able to find oxidation states in the given complexes. Done with this? Okay, let me move forward. Yeah. So they will be asking you to say this, which are the following complex complex ion has electrons that are symmetrically. Yes, we will come back to this. First of all, you need to know the basic things first. Let me explain this. Look at here, the types of complexes if you talk, there are 2 types. See, it is asked in JEE Main 2023, very easy, within seconds you can answer. So what is that? See, they are saying the complex, the homoleptic and octahedral complex of cobalt plus 2 and water has dash unpaired electrons in T2G set of the orbital. See, homoleptic and heteroleptic, these are the 2 terms you have to be clear with. Okay, so homoleptic means in the given metal complexes, all the ligands attached to this metal atom should be same, then I can say it is homoleptic. If more than one or more if there are different types of ligands in the metal complexes, then you have to say it as heteroleptic. Look at here, cobalt plus 2 complex, CO plus 2 complex is made up of cobalt and water only. It means octahedral complex means there should be 6 water molecules. Right now, what is the charge mentioned here? Plus 2. So take it here, plus 2 charge. So this is a cobalt plus 2 complex given, and octahedral means yes, this is the octahedral complexes. Now homoleptic means all the 6 ligands are same, that is water molecules only. Now what is the next thing they are asking? Number of unpaired electrons in this. Just now I told you for iron. So what I told you, cobalt, first write its oxidation state, cobalt plus 2 now. For cobalt in atomic state, we have atomic number 27 now. So write it as 3d7, okay, and this as 4s2. So what is the electronic configuration? 3d7, 4s2. This is how you can remember its electronic configuration. In plus 2 means, plus 2 oxidation means from here to here you remove 2 electrons, becomes 4s0, 3d7. So it will be 3d7, 4s0. Okay, hope up to here it is clear. Now they are saying T2G set electrons, T2G set orbital electrons they are asking. So how do you give this T2G set electrons? See, it is purely, again you need to know about CFT, crystal field theory. Okay, what is that? So here we have in d orbitals we have dxy, dyz, dzx, like this now, dzx and dx square y square and dz square. These are the orbitals we have. Out of these, the first 3, those orbitals which are along the axis are this, are in between the axis. See, these are xy, it means this is d orbitals are between x and y. Let us say this is x axis, y axis, like y, x I have, this is a orbital, d orbital present here. Okay, so dxy, dyz, it means in between the axis with angle of 45 degrees you can remember. Okay, so now these are along the axis, it means like this, along the axis is something like this. Okay, so 2 set of orbitals are there. So those orbitals in between the axis forms T2G set orbitals. So these 3 are T2G set orbitals, like this, 3 T2G set, and which are along the axis are EG set orbitals. Here I am writing dx square y square and dz square, and in between the axis dxy, dyz, dzx. Okay, here I am writing. Now how many electrons are there? D electrons, 7 are there now. So first, what is the nature of the water? It is a weak field ligand, therefore you just need to fill the electrons as in the free metal. It means what? 7 electrons now, 1, 2, 3 over 4, 5 over 6th electron and 7th electron. This is how you need to fill the electrons. Okay, so now tell me, read the question once again. The homoleptic octahedral complex of cobalt and water has dash unpaired electrons in the T2G set. So in the T2G set, this one is what? T2G set, and this is EG set. How many electrons are there in the T2G set? In this T2G set, so only one unpaired electron is there, so your answer should be 1 here. If they ask total number of electrons, count 2 plus 1, 3 you should say. If they ask only EG set electrons, your answer should be 2. So based on the question they are asking, you need to give your answer. Hope this is also clear now? Yes, if it is clear, yes, tell me in the chat box, and also you can click on the like button. Yeah, let me move forward with one more question. See, Wilkinson catalyst. What is Wilkinson catalyst? In Wilkinson catalyst, the hybridization of central metal ion and its shapes are respectively. Again, JEE mains question. What they are asking? Hybridization of the central metal atom. So what is the Wilkinson catalyst first? That is RH, PPH3, triphenyl phosphine, PPH3, 3 times Cl. So this is what the Wilkinson catalyst here. So now what is the hybridization of this metal atom? Rhodium is a metal here. See, for rhodium it is X. Let us say oxidation state. Find oxidation state first. 3 triphenyl phosphines are there, 3 into 0, each one oxidation state is 0. So overall it is 0, and chloride ions are 1 with charge as -1. Okay, -1 is the oxidation state of chloride ions. Overall is a neutral molecule, take it as 0. So equals to X, its oxidation state equals to +1. So rhodium is in its +1 oxidation state. Okay, now rhodium, cobalt, rhodium, this belongs to same group now. So it will be having what is the electronic configuration? Now it will be, I can write like n-1d. See, for cobalt we have written just now D7S2 we have written. For this it will be D8S0. Why it is D8? So one electron here jumps over here, since the principal quantum number increasing, so I can write 3D8 like D8S0. So this is the electronic configuration I am writing, D8S0. Okay, so now because 9 electrons are there in this particular group of elements, 1 electron is removed as its oxidation state is +1, so remaining 8 are there. Write those 8 electrons. Now after doing that, so now just fill these electrons 1, 2, 3, 4, 5 and this one. Okay, write 1, 2, 3, 4, 5 electrons, 6, 7 electrons and 8th electron. Up to here it is clear now? See here, this is n-1 level d orbitals, this is ns. After this we have np also now. Yes, np 0 electronic configuration. So now by using this, see how many ligands are there here given? 3 plus 1, 4 ligands are there. Now total number of coordination number is 4. So with coordination number 4, either we have possibility for sp3 hybridization or for dsp2 hybridization. Out of these two, only one possibility is there. Since here the complex is metal atom is having higher coordination number, we are writing its electronic configuration like this, and the ligand here it is showing the pairing of electrons takes place due to this ligand nature. Therefore this pairing of electron takes place, so that we are getting something like this after pairing 1, 2, 3, 4, 5, 6, 7, 8. Okay, like this. So what are the orbitals we have here? 1 empty d orbital, 2 this, 1 ligand and 1 s and 2 p orbitals. So what is the overall electronic hybridization we have? dsp2, 1 d, 1 s and 2 p. So dsp2 is a hybridization of this complex. Okay, and you know, for dsp2 hybridization, what is the geometry we can get? So it will be square planar. What is that? Square planar. For sp3 geometry will be tetrahedral, for dsp2 it is square planar. Yes. Okay, so this is how you need to answer. Now my question for you is, what is the nature of the complex, whether it is diamagnetic or paramagnetic? So how can you give this, whether paramagnetic or diamagnetic? If the given complex contain any unpaired electrons, consider it as paramagnetic. If no unpaired electrons, consider it as diamagnetic. Hope this is also clear. Okay, so now again for diamagnetic complexes, magnetic moment value will be 0, but for paramagnetic complexes, they will ask us to find what is its magnetic moment value in terms of Bohr magnetons. Okay, I will show you one question based on that also. Okay, so now let me discuss the other questions given here. Here I have one more question. When AgNO3 solution is added to excess to 1 molar solution of CO cobalt trichloride dot X NH3, 1 mole of AgCl is precipitated or formed. What is the value of X? See, very easy, and this kind of questions we will also be seeing in the solutions chapter in colligative properties applications. Okay, look at here very carefully. See now, when this molecule is treated with AgNO3, what's going here? So it is forming 1 mole of AgCl. It means this AgNO3 is reacting with chloride ion. How many chloride ions are available? Only one chloride ion is available in order to form one AgCl, right now. So it means from this molecule I can say one chloride ion is staying outside, okay, remaining are inside. So I can write cobalt NH3 and Cl. So how many Cls I should, out of these 3 only one is outside. So this ion, whatever the ion outside this coordination sphere can involve in the reaction, that inside the coordination complex they won't lose their identity, it will be a stable species now. Okay, so these chloride ions won't react, only outside one will react. Out of 3 only one chloride ion is outside, that's why we are getting only 1 mole of AgCl. Therefore I can adjust inside this coordination sphere 2 chloride ions and outside as 1. Okay, so now in order to make the complex as hexadentate or octahedral complex, we have 2 inside chloride ions and remaining 4 should be ammonia ligands. So what is the value of X? I can say here value of X can be 4. What is the value of X? X can be 4. Hope this is clear. So this is purely what? Based on the precipitation, number of ions precipitated. Okay, so now we will get CO NH3 4 times Cl2, okay, with positive charge. So these are the things we will get after adding AgNO3. And here you know what is the spectrator ion or anionic ion will be nitrate ion like this. Okay, like this. This is a scenario we will be seeing. Now they will also ask what is the Van der Waals factor for this I value in terms of solutions, colligative properties. See how many ions we are getting? 2 ions now. So its Van der Waals factor is 2 in the aqueous medium. This complete complex has 1 ion and this chloride ion is the other one. So 2 ions, so its Van der Waals factor is 2. They are asking about the value of X. So value of X is how much we got here? 4. So take it as answer number B. Okay, this is your answer. Let me move forward. Yeah. So here, which are the following complex ions has electrons that are symmetrically filled in both T2G set and EG set orbitals. So how do we do this? Symmetrically filled, it means same number of like electrons in EG set and T2G set should be observed. Okay, so now if you observe these complexes, cobalt complex here we have, what is the oxidation state here? So 3 fluorides are there, so find it, you will get it as +3. So for +3 we will get 3d6 4s0. Okay, 3d6 4s0. So all of them are octahedral complexes only now. So we have T2G set down and EG set up. So here I am writing EG T2G. So just find number of electrons in each case. 6 electrons now. All the 6 electrons where they will fill, that is how you need to check. And what about this cobalt? Here it is in +2. So right here 3d6 or 7. 3d7 4s0 is the electronic configuration in this case. Okay, now what about in this case Mn+2? So Mn+2 is the oxidation state. I hope you know how to calculate. I already shown you. Take this as X plus 6 cyanide, 6 into -1, okay, equals to -4 is the charge present on it. So X value will be +2. This will be the oxidation state of manganese. Like that you can first find the oxidation state, write their respective electronic configuration. See, manganese will be having atomic number 25, so 3d5 4s2, but it is in plus 2, so write 0 here. Okay, now in this case what happens? So here iron plus 2 or plus 3. See, iron X plus 6 into minus 1, overall charge is minus 3, so that you will get iron with plus 3 oxidation state. After doing this, write its electronic configuration. So it is atomic number is 26, so you should get 3d6 4s2. Okay, but 3 electrons should be removed, so it becomes 4s0 3d5 like this now. Now fill the electrons. See, 1 electron here, 2 electron, third electron. In the iron case I am filling first. Okay, 3 electrons are done, and see, given ligand is weak field ligand, therefore electron should be filled symmetrically. After filling down, you have to go for higher, like as in a free metal. Okay, like this. This is a symmetrical distribution of electrons in the iron, fourth option. Now if you consider the other options, see in the manganese, this complex, what happens, you know, so you need to fill all these electrons. How many electrons? All the 5 electrons are there now. That should goes into lower energy level only, like T2G 5 and Eg 0 electronic configuration you will get. First you need to fill all the electrons in the lower energy level, then only you have to go for higher energy level in case of this kind of strong field ligands. Okay, so that's why option number 3 is incorrect. Okay, and most properly answered question, properly or appropriate answer for this question will be fourth option. In case of second option also you can look here, cobalt plus 7 now, it means what happens again? Ammonia ligand. Here it is strong field ligand. So first you need to, in the case of strong field ligands, what I am saying, first fill the electrons in the T2G set. It means lower energy state. 1, 2, 3 over 7 electrons are there, and given ligand is strong field ligand for cobalt. Okay, 7, 4th electron, 5th electron, 6th electrons, and 7th electron goes here. So I can say T2G 6 Eg 1. Okay, so this is somewhat unsymmetric now. See, all the 6 electrons here, only 1 electron in the up, so I can say this is unsymmetric. Similar to first option also, it is also unsymmetric. The most proper answer for this question is option number 4, which is having more symmetric. Okay, so now this is what? Crystal field theory, right? So you will be studying this in the crystal field theory. Okay, so I hope it is clear. Whenever you have octahedral complexes, remember this point. Whenever you have octahedral complexes, there are 2 types of splitting. One is T2G set, another one is EG set. Okay, 2 set of orbitals will be there. EG set, T2G set orbitals down, EG set orbitals up. How many T2G set orbitals? 3. Okay, see, dxy, dyz, dxz, xz, like that. And what about EG set? Along the axis, what are the orbitals? We have dx square, y square and dz square. Those are EG set. Now, in the case of weak field ligands, you need to fill the electrons as like in the free metal. It means you fill the first 1 electron here by following Hund's rule, and go the 4th electron here, fill the electron into the EG set. This is the filling way pattern when you have weak field ligand. But when you have strong field ligand, what happens? You need to fill all the electrons in the lower energy only. Why? Because in the case of strong field ligand, its name itself is saying the strong field, this orbital splitting will be very greater extent. Therefore, all the electrons first should be filled in the lower energy state only, in the T2G set only. First, how many maximum electrons we can fill here? So 3, 4, 5, 6, like that. You can fill maximum of 6 electrons in T2G set. Then only if you have any extra, you have to fill in the higher energy state. So this is what the pattern you should follow. So in case of weak field and strong field ligands. Now can you answer this question? Yeah, can you answer this question based on my explanation? So spin only magnetic moment. So how do you find? First find its oxidation state, Mn plus 2. So D5 S2 now, S2 means plus 2 means remove 0. Okay, now how many unpaired electrons are there out of these 5? Okay, since it is weak field ligand, all the electrons are filled as following Hund's rule. So you will get 5 unpaired electrons. So 5 unpaired electrons means what is the magnetic moment formula? Root over n into n plus 2 Bohr magneton. Yes, substitute 5 over here. So you will get mu equals to root over 5 into 7 right now. So root 35 will be how much? It is around 5.9. Nearest integer value will be 6. So this is your answer. 6 Bohr magnetons will be your answer. Yes, hope it is clear. Now I will be showing you few questions. Just give a try and tell me the answers in the chat box. We will discuss in the upcoming session. So take the screenshot of these as well as this one, ligand field strength, and yeah, so these are the two important questions. Take it as homework. We'll discuss them in the upcoming session. Thank you for watching. Stay connected with us.